Alright, time for another draft physics video presentation. Yeah, difficult video to make. I have to concede part of the argument was made poorly by me. The Quora people are correct to, if you throw something at twice the velocity, it does in fact go 4 times as high in gravity. Okay? Because to make it go twice as fast, you have to raise it 4 times higher. That's the catch. So I wasn't appreciating that gravity is almost too perfect a spring in that it only pushes back, again like car brakes, it only pushes back a certain amount, and so velocity will, it gives things that are faster an advantage. So the faster you're going, the more distance you'll travel in gravity against it, because it's only pushing per second. It's only pushing based on time, and it's not paying any attention to how far you're moving in the gravity while it's pushing. So, ironically, in the first moments, the first second of gravity, you only travel 4.8 meters. So even though you're going 9.8 meters a second after that first second, you only traveled 4.8. So your average velocity is, how much you're gaining is high because of that short distance. And then when you double the distance, you're still not going twice the speed. That's the catch. You have to wait quite a while before you actually have doubled your velocity. You have to wait, and after the second, ironically, it all kind of evens out because your miles per hour and the amount of gravity you've used will match. But it's still not half because you only went 4.8 that first time, and now that you've finally gotten to twice the gravity in 2 seconds, twice the speed of gravity in the 2 seconds, it's still 4 times more than throwing it. The point is all I have to do is throw it 4.8 meters. All it has to travel is 4.8 meters to go 22 miles an hour. But to go 44 miles an hour, I have to travel 4 times that distance before I have that speed. So the way I wanted to, so this doesn't change the fundamental argument about momentum versus mv squared thing, the kinetic energy equation. So Martin was nice enough to post a very long comment. I saw this after I had already, I put the video on, it's not deleted, it's just that it's not public in the public sense, linked. And I'll decide whether it's worth deleting or not. I mean, it is plainly just a bad video on my part. Funny and dramatic, but all wasted jokes, I'm afraid, because the joke's on me, because I was wrong. So anyway, so there's a very long comment, and I really, he thinks he's making it very easy to understand, and no, it's not any easier, sorry. I'll read it 2 or 3 times and see if it gets any better, and it's got some jokes in it too, which I don't really need. But anyway, it's a lot of typing. That's a lot of typing. So I do appreciate, I will read it, try reading it more than once and see if I can get the print of it. Part of it is even the notation is a little bit E-mon. I don't know, E-mon? I guess that's energy from momentum? I don't know. Anyway, yeah, not very helpful. So look, what we're really talking about is you have the simple equation of your mass and your velocity, and then you have, and that's basically, I would argue, that's your energy. You can't have any energy in any other form than that. And there is no other, oh, come on. Yeah, there it went. In the alternative theory for your, what they call kinetic energy, as if there was some other kind of energy, And this would include kinetic / potential, I guess. And that equals some kind of 1/2. All right, it started out without the half. Let's recognize the mass, okay, times the velocity squared. And that's a lot different. This seems a lot weirder. And it's basically saying, 1/2 the mass, and then you square the velocity. And with some numbers that doesn't matter, like a 4. 1/2 of 4 is 2, and then 2 squared is 4. So sometimes it doesn't matter, but it's basically saying the mass is becoming unimportant and the velocity, it's all that matters. And that's defining your momentum. So the argument would be I hate to erase that because it's really the key point here. But anyway, so the argument is those two numbers don't match. Okay, they give you they give you a statement about what the energy is that, in my opinion, is just not useful because it's they don't match. You can't be right. One of them's got to be right, one of them's got to be wrong about what your energy is. Your energy can't be both of those things because they're not the same number often. Okay, so how do I want to illustrate this? See, everything accelerates something a different way. So like I said, the gravity argument is something's falling. So something's sitting up here in gravity. Gravity is, my point is just like rain. It's just stuff and you collect it. And so you're just figuring out how much does it collect. Well, it's collecting at a rate, okay, that's completely dependent on time. So all it's saying is yeah, a certain amount of it's going to hit you in 1 second. And it really doesn't, your speed does matter, but you have to go really fast to start outrunning the rain. The rain's going pretty fast. All right, so the speed of light. So you don't have much chance of outrunning it. So that's really not an issue with these kind of equations. So the rain is just hitting you at a constant rate, and in 1 second, I guess we'll say time, you're going to get hit with a certain number of raindrops. So whatever it was, 16 we could say. And then you'll get hit in the next moment of time with 16, the next period of time. But obviously as you're getting hit, you're starting to move. You're not moving very fast. So this first second, you're not moving very fast. Because right here you're only moving, one drop hits you, got spread out over all your little bits, okay, it moved them all a little bit. Then we have to wait for the next drop and the next drop and the next drop. And so, by the time you get here, you are going, let's just make it, 10 meters a second. Okay, you have reached the velocity, but it only took you only traveled 4 meters because you were going really slow most of the time. Most of the time you weren't going very fast. Well, now you're going very fast because you're going this 10 meters plus all the new rain that's going to hit you. So you go a much further distance before 1 second happens. One hunk of time that equals this much more velocity. So you're only going 20 meters per second here, but you travel a lot further. So the 20 meters represents how many bits hit you. And how many bits hit you is based on these time intervals. So you only got 16 in this tiny bit of space, and you collected 16 over this longer space here. So your velocity still will be 20 meters per second. So your velocity is lagging the distance you're traveling because the time, the rate of the energy being added is slow. Now the same thing happens in the opposite direction. In the opposite direction you have this great deal of velocity, and so you're moving fast, but it's only dropping 16 a second. So you're still only hitting 16 a second. So it can only knock so much off of your velocity in that, in that first, as you're traveling, it can only slow you down so much because it only hit you with 16 in this giant amount of distance again. And you'll just do the opposite thing. You'll come slowly to a halt, and this last distance you travel will be very short, but your change in velocity will be very high. So because you'll go from 16 to 0, where it took this far for you to change 16 worth. So you change 16 worth here, and you change 16 worth here. So that's where it gets slightly confusing. So the nature of so I'm not really prepared to make hard statements about how all these different velocities work, but you can understand that it's all about how something's accelerated and decelerated. And so gravity would fall into a force that's very even. Okay, it does exactly the same thing. Every position you're in, it's doing the same thing. It really doesn't care how fast you're going. None of this matters much. All that matters is it's trickling it in at a certain rate. So it'll slow you down slowly, and it'll speed you up slowly. Okay, and that's the rule. But as say, if you're a bullet inside a gun, now the rule is going to be kind of different, because when the charge explodes, okay, you're going to reach your maximum velocity very early, and then the rest is just going to be the slowdown. So your maximum velocity is going to be shortly after the end of the, I don't know how far after the gun, but the charge from the gun is only going to go so far in pushing you, and that's when the pushing stops, is when your velocity stops. So your maximum velocity will be whatever, a foot away from the gun, and then the rest of the trip is just slowing down. And so this is accelerating over a much shorter distance, accelerating a lot more. And I don't know what the exact efficiency is of the amount of momentum, the total momentum of the charge as measured, as a compression force, and how much you're getting into the bullet, but it's pretty high. I mean, you're forcing the explosion essentially to go one way, and the bullet's hard enough where it has to accept the pressure, and so it has to move, and so you're forcing the little bits of energy into the bullet very fast and getting away with it, much faster than obviously gravity does it. Gravity is pretty slow at pushing you. All right, so it all comes back down to the fundamental argument is all you're really saying is that momentum in two objects, okay, that are inversely created. This one's twice as heavy, okay, it's two masses, and it has one velocity, and this one has two velocities and one mass. And the argument is that by kinetic energy, this one you could say is 2 tons moving 6 miles an hour, and this is 1 ton moving 12 miles an hour, and that's where this started. And the argument is that by momentum's equation, they have an equal amount of energy, okay, mv. They're equal in terms of how much energy they have. The kinetic formula says this lighter object moving faster somehow has twice as much of something called energy, and that somehow when you move this one into this one, you conserve it, and when you move this one into this one, or cause the exchange, you lose it. That's the part that doesn't make any sense. And I would argue is that you can't realize whatever this extra energy this one has, that it's not realizable, that you can never extract that extra energy through any other benign experiment. There's no experiment I can do where I can get this claimed extra kinetic energy, okay, that exists here. It has 2x, 2 times, however you want to put that, the energy. But how can I ever capture the fact that it does? What experiment can I do with these two objects that will demonstrate that this one has real energy? Like, is there any way I can make them turn a turbine or something? So the argument is if I have them turn a turbine, that is, I have them, roll and bang into turn a wheel, that they're in fact going to turn the wheel the same number of times. I can't make this one turn the same wheel twice as many times as this one turns the same wheel. So this extra energy can't be real because I can't get it out of a system. I can't make this one make more energy. I can't extract it in any form. And all I can do is for display purposes, right? I could crash this into a wall, and I can crash this into a wall, and the two things will bang into the wall and make a mess in a different way. But it's going to be, if I add up all the pieces are still going to fly off, and all you're going to have is this piece can fly off, this one off, this one off, this one here. When I add up all the pieces, I'm still only going to have the momentum. The vectors that were their momentum is the only thing I can knock pieces off, and it'll be the same thing as just knocking pieces off this momentum. So everything that flies off, even if it looks different, some pieces are lighter and going faster, some pieces are bigger and going slower. If I just add up all that energy, I'm still just going to get that these two have exactly the same energy, and that the total energy is this one's energy plus this one's energy, and that's all there is. I'll never be able to find this extra 2x of kinetic energy. So the argument is this kinetic energy can't be defined as being anything. There's no point in deriving it. And if the derivation is based merely on a gravity experiment, where they put they put a weight 4 times higher than another weight, same weight, put it 4 times higher, and it goes 4 times deeper into a piece of clay. Now, the truth is it should have only gone half as deep if it was a better experiment. That would be my argument. If it was a spring, you would have found that this one that fell from 4 times higher has exactly the same momentum as this one that is, that this one's 4 times higher than. That they're going to have, no, this one will have only 2x the momentum. If I quadruple its height, I'm only going to double its momentum. So it can't have 4x the momentum of this one, it can only have 2x. So if the experiment was done with something besides clay that just dented, this one should dent a certain amount, and this one should dent twice that amount, and there shouldn't be any 4x indicating the existence of this kinetic energy. So I'm just saying that that's the real experiment. That's the one we need validation through, is an experiment that measures the momentum of something dropped from 4 times higher, because its momentum is only going to be 2 times higher, because it's really only going twice as fast here. So even if it's 4 times higher, it's only going twice as fast. So to get twice the velocity from gravity, you have to go 4 times higher to get it. And this simple, so I've already said simple enough. If somebody can show me the equation where, or the experiment I mean, where they took two things that have different kinetic energy but the same momentum, take those two things and show me how you can ever extract the extra kinetic energy. How you can ever take it out of use the two things to actually extract it. Not by saying it goes 4 times the distance, but that's not extracting it. I mean actually turn a windmill, or turn something, move something. Show that that is true. That somehow this thing has twice as much energy, even though it has exactly the same momentum. That's the paradox, that's the problem. The physics doesn't make any sense in this state. It doesn't make any sense to say this has twice the kinetic energy, even though the kinetic energy is useless and can never be extracted. There's no point in saying it has twice as much energy, but the energy doesn't really exist. That's the argument. Alright, and my apologies for the previous video. I wasted just such great drama. Comic drama, but drama. I'm really, damn it. Got that one wrong. Anyway, so it happens. It's really hard to be perfect, and it's hard to be not generally infallible. It's hard not to be. it's hard to be, and that's why it's hard not to be a mess, because this is all difficult. But anyway, it just it's just discouraging, because this has been so difficult. But it just proves that nobody's watching, except for Martin. There's nobody paying any attention to these videos who can know better, or say better, or explain better, or articulate better, and that's really the real problem. So anyway, Einstein had his cosmological constant, so we all make mistakes. Much clearer. Anyway, so I'll leave it at that, and I will try to find even a better way to say this. I think that's pretty clear. So the idea is to find an experiment where two things have mathematically the same momentum, yet one of them has mathematically twice as much kinetic energy. And is there any experiment where you actually can collect the extra kinetic energy, where you can show how you collected more energy even though they had the same momentum? Okay, leave it at that. Oh, till the next time and such. Alright, I don't need to go up there. I can all do it from down here. So, till the next time, this has been a DraftScience video presentation.